Good morning to everyone present here. My name is Sashpreet. I am completing my bachelor's in Artificial Intelligence and Data Science at Nitya Meenakshi Institute of Technology. Today I'm going to be talking about green buildings. But before we dive into the topic, I would love to thank my sustainable teacher, Mrs. Malia, for always supporting me and helping me with this project. Well, green buildings, the future of sustainability, is not just a topic which is about construction or design. It is deeply tied to our environment, our economy, and our well being. By the end of this presentation, I hope you'll see how green buildings are essential for a livable and healthy future for all of us. Now, let's talk about traditional buildings. Well, when you look around yourself, what do you find? You find high, tall standing buildings, apartments, offices, and institutes. All of these have been made with steel, concrete, cement, bricks, and some of these materials aren't really environmentally friendly. So, traditional buildings come up with several major issues that harm both the environment and the human well being. Let's look at some of them. The first one is high energy consumption. About 40% of the global energy is consumed by these buildings, mostly for the purpose of lighting, heating, and cooling. Without energy efficient system, this leads to excessive use of electricity and increased emission. Secondly, we rely on polluting materials like concrete and steel. These materials have a huge carbon footprint due to the energy needed for their production, contributing heavily to global warming. Third is poor insulation. It is the most common issue. Without proper insulation, buildings lose or gain heat easily, leading to more use of air conditioners and heaters, again raising energy use and cost. Lastly, urban heat and pollution become worse with dense, unsustainable construction. These buildings trap heat and block airflow, raising city temperatures and worsening air quality. Now, what is a green building? A green building is a structure designed to be environmentally responsible and resource efficient throughout its life cycle. The goal is to reduce negative environmental impact and improve the quality of life for the occupants. There are four core principles that define a green building. Eco-conscious design. The building layout makes smart use of natural resources like sunlight, wind, and shading. Efficient resource use. Green buildings conserve energy and water through advanced technologies and thoughtful design. Sustainable materials. These buildings avoid harmful materials and instead use recyclable, non toxic, low impact products that can be used in a circular economy. Occupant well being. Design also focuses on good indoor air quality, comfort, natural lighting, and acoustic performances. Now let's know about some key features of green buildings. The first key feature is solar panels and renewable energy. One major feature of green buildings is using renewable energy. These reduce dependence on fossil fuel, lower electricity bills, and significantly cut down on carbon emission by generating clean, renewable power on site. Green buildings become much more sustainable and cost effective in the long run. Natural ventilation and thermal insulation. This allows smart placement of windows, vents, and shading devices. Buildings can maximize airflow and reduce heat gain or loss. Proper insulation helps maintain comfortable indoor temperatures year around, reducing the need for artificial heating and cooling. Rainwater harvesting system. Green buildings often include rainwater harvesting system. These collect and filter rainwater, which can then be used for non-drinking purposes like flushing, toilets, gardening, and cleaning. This not only saves water but also reduces the strain on municipal supply systems. LED lighting and motion sensors. To reduce energy use, green buildings use LED lighting, which is much more efficient and lasts longer than traditional bulbs. Paired with motion sensors, lights are automatically turned off when rooms are empty, which further cuts down on energy waste. Native landscaping. Green buildings use native plants for landscaping because they need less water, fertilizer, and maintenance. This approach supports local biodiversity, reduces landscaping costs, and enhances aesthetic value of building surroundings. Recycled and low carbon materials. These buildings also emphasize the use of recycled and low carbon materials like using fly ash bricks, bamboos, and reclaimed wood. They also avoid using substances like VOC heavy paints. This significantly reduces the building's overall environmental impact. Rainwater harvesting systems. Green systems treat wastewater from sinks, showers, and washing machines. Once treated, this water is used for irrigation and toilet flushing. It's an efficient way to conserve fresh water and manage wastewater sustainably. Daylight and smart glass. Green buildings are designed to allow natural daylight into interiors, reducing the need for artificial lighting. Smart glass can adjust transparency to control glare, heat, and light, enhancing comfort while saving energy. Energy efficient wax systems in green buildings use sensors and automation to optimize air quality and comfort while using less power. Smart control monitors the room condition and adjusts ventilation or cooling in real time. Green roof and green gardens are an excellent addition to green buildings. They act as natural insulators, reduce the urban heat island effect, filter air pollutants, and even absorb rainwater. They also create relaxing green spaces in dense urban environments. Smart building management system use real-time data to control lighting, WAC, water, and energy systems efficiently. They help reduce energy waste and allow building operators to maintain performance and comfort through automation and analytics. Now let's look at some of the benefits of green building. Let's look at the environmental benefits first. Well, they use 25 to 50% less energy by optimizing natural lighting, using smart appliances, and relying on renewable energy sources. They also save up to 30 to 40% of water throughout rainwater harvesting and rainwater reusable system. Most importantly, they help reduce the building's carbon footprint. Traditional buildings are responsible for about 35% of the global carbon emission, while green buildings significantly cut this down. They also generate up to 70% less solid waste, making them not only energy efficient but also eco friendly in every way. Health and social benefits. Green buildings are designed for people too, not just for the planet. They ensure improved indoor air quality by using non toxic materials and proper ventilation. This lowers health risk from indoor pollutants. Natural light, greenery, and quiet interiors helps promote better mental health and productivity, especially in workspaces and school. Simply put, green buildings create healthier, happier environment. Economic benefits. While green buildings have slightly higher construction costs, they offer huge economic advantages. They can lead to an 8 to 10% increase in the property value thanks to lower operating costs and high resale demand. Most importantly, they result in lower electricity and maintenance bill. With features like solar power, LED lighting, and smart wax system, owners recover the extra cost in just 3 to 5 years on average. So they are not just good for the planet, they're great for your pocket too. Now let's look at one of the famous case studies of Infosys campus in Mysuru. It is one of the most famous green building in India with an IGBC Platinum rating, the highest recognition for sustainable buildings in India. Now, the campus incorporates smart lighting and systems that adjust based on occupancy and daylight. Large windows and shading devices allow maximum daylight while reducing heat, cutting down artificial lighting needs. A standout feature is its radiant cooling system, where chilled water circulates throughout the pipes in the ceilings and floors to maintain indoor temperature. This method uses 30 to 50% less energy than conventional air conditioning. Water sustainability is an important and another strong point. The campus treats and reuses 100% of its wastewater for landscape irrigation, flushing, and cooling. Rainwater harvesting also helps replenish groundwater. Infosys Mysuru is a model of how smart design and sustainability can create efficient, healthy, and eco conscious workspaces. Let's look at Edge in Amsterdam, often called the world's smartest and the greenest office building. It spans about 40,000 square meters and holds an LEED Platinum certification with one of the highest rating ever, that is 98.4%. What makes it truly unique is its 28,000 IoT sensors that monitor light, temperature, air quality, and occupancy. These sensor auto-adjust systems in real time to maximize comfort and reduce the usage of energy. Employees use an app to control lighting and climate at the desk and book workshops or parking. This connectivity enhances both efficiency and personalization. Edge also generates its own power using solar panels, making it net positive energy building. Rainwater is harvested for flushing and irrigation, while green spaces improve air quality and aesthetics. It is a primary example of how smart technology and green decision can redefine modern workspaces. Now let's look at the last case study, CII Godrej Green Building in Hyderabad. It is India's first LEED Platinum building, setting a benchmark for green architecture in the country. It was built in 2004. The building uses solar power light shells and north-facing glazing to reduce heat while maximizing daylight, cutting down electricity use significantly. Its rainwater recycling system allows low-flow fixtures to lead a 40 to 50% drop in water use. Locally used materials like fly ash bricks were used in construction to reduce the carbon footprint. Smart wax system use automation, sensors and thermal mass to reduce energy use, improve air quality and maintain comfort efficiently. This building proves that sustainability can be both functional and inspirational. But is green building really worth the cost? Many people worry about the higher initial cost because green buildings too typically cost 10 to 15% more than traditional buildings. But this is a very short term view. Green buildings consume 30 to 50% less energy, 30 to 40% less water, and needs less maintenance due to better system. They offer a faster return on investment, just 3 to 5 years compared to 8 to 10 years for conventional buildings. Plus, the indoor environment is healthier and more comfortable. So, yes, green buildings may cost more upfront, but the long term savings and health benefits far outweigh the investment. But how can we really promote green buildings? We need to make sure that it is not just an exception, but it becomes a norm. For this, we need a collective effort from the government, industry, academia, and public. Firstly, government initiatives play a really important role. They can help us with tax rebates, faster clearances, or subsidies for renewable energy and sustainable material. Can encourage builders to adopt green practices. In India, many states have offered extra floor space index to projects that meet green norms. Next, we have green certification for real estate such as GRIHA, that is Green Rating for Integrated Habitat Assessment, and LEED. These certificates help builders to meet the eco standards and give buyers some confidence they are investing in a sustainable project. Promoting these can shift market preferences towards green projects. We can also help build awareness at college level. By encouraging students to take up sustainability focused projects, green tech competitions, or awareness campaigns, we can instill eco friendly means. The image here shows an example of this. Now we conclude the topic. Green buildings aren't just walls and wires, they're about hope, health, and a livable planet. By making a curriculum in engineering and architectural education, we can help the future professional be trained in energy modeling, sustainable material, and green design principles. It will help them naturally apply in their future projects. Promoting green building isn't just about new construction, it's about changing the mindset, education, and policy framework that shapes the built environment. Thank you.